Welcome to today's webinar on designing smart lights for smarter cities. My name is Joseph Waring, and I'm the Asia editor for Mobile World Live, and I'm your moderator for this session. Street lighting has undergone a huge technology shift over the past 20 years and continues to evolve rapidly. The number of connected street lights deployed globally is expected to increase to more than 73 million over the next 8 years. A major driver of these deployments is the widespread rollout of low-power, wide-area networks, most notably narrowband IoT, featuring low energy consumption and extensive coverage, both indoor and outdoor. At the end of November, a total of 77 mobile operators had launched commercial mobile IoT networks. China's 3 state-owned operators were early adopters of NB-IoT networks, and the country leads the world in IoT network deployments. In the U.S., AT&T, Verizon, and T-Mobile have all rolled out extensive IoT infrastructure. Vodafone has done the same in 7 countries in Europe and announced in September plans to double the number of European cell sites supporting its NB-IoT network at the end of 2019. GSMA Intelligence forecasts global cellular IoT connections to hit nearly 1 billion by the end of this year, up from 640 million at the end of last year. The advantages of smart lighting are many, from improved energy efficiency to lowering OpEx to reducing carbon emissions. This webinar will examine how IoT networks can not only reduce cost, but also enable a variety of new smart city services related to things like public safety and environmental monitoring. Our first speaker today will be Milena Milosevic, who is responsible for customer programs and business development at Telit, with a special focus on smart metering and smart cities in EMEA. She joined Telit in 2006 and has been instrumental in analyzing industry trends, identifying new business opportunities, and developing the company's strategy. Our second speaker, Sternberg, is responsible for global marketing at Telematics Wireless, Smart City Solutions and Technologies, including street light control networks. He has been with the company since 1996. After the 2 presentations, we'll take answers from the audience. If you look below your screen, there's a box where you can add questions at any time throughout the presentation. Before I hand things over to the first speaker, we're going to launch a poll question. The question is, what type of connectivity technology are you currently using for smart lighting? We'll share the results after the presentation. Milena will now start by outlining how smart lighting is a key for developing smart cities. Over to you, Milena.
Thank you, Joseph. It's good to see. It will be interesting to see from the poll audience if some of you are already involved in the smart lighting deployments. Thank you all for joining. I'm sure you've noticed that there's been a lot of excitement during the last few years around smart city street lighting. And as many consider this the foundations of the smart city itself, that's why we decided to put some press release as opening for the webinar. Still, there are many challenges for municipalities to overcome. Main problem, of course, are the fundings, but there are also technological challenges to have the system which is future-ready, secure, open, flexible, and proven user cases. And during this webinar, we'll try to provide some answers on how we believe new cellular technologies can fit their needs. So smart lighting has been around for a long time. It started in early 90s with connected lighting controls, leveraging the utilities expertise in power line carrier or PLC technology. And this quickly extended to wireless with protocols including Zigbee, Z-Wave, wireless M-Bus, and many other proprietary star mesh topologies, mainly in ISM band. Network lighting was restricted to the local control, only or networks to the remote head offices and control centers through the cellular gateways. But today we see smart lighting evolving quickly towards connectivity manufactured directly into the bulb and fixtures. Smart lighting will play the major role in smart cities across the globe, and we also see trends in the cities are changing. It's not only about improving the energy efficiency and reducing costs, which has been the main objective for a long time, but also providing a path towards a smart city. And this can be achieved by including the connectivity in the lights. They have the power, the lights have the power, they cover vast populated areas, and it's the easiest way to connect the full city. So I would like to go quickly through some of the main benefits of smart lighting. Let's start with energy efficiency and cost reduction. Why the smart lighting is so important in the smart city ecosystem? Because cities can build a clear business case with a reliable return around it. You can easily find information in any analyst report on the important cost reduction and improve the energy efficiency with the new LEDs. So we're talking about 70 to 75% of reduction in the cost. 50% is coming from just switching to LEDs, while 20 or more percent will come from operational costs over lighting controls. Also, by adding a control and monitoring system, municipalities allow predictive maintenance, full diagnosis, and most important, better service towards the citizen. And this is where the future cities are shifting their attention today. So as you've seen, the LED light conversion pays for itself, but you can actually take it further and turn it into a valuable resource by adding connectivity. This ensures the real-time data from different sensors to a central service. It builds an ecosystem around it and generates big data that city needs to offer digitalized services and better quality of life for the citizens. If we look into what could be the most promising cellular technology for the smart lighting, I would consider the most relevant narrowband IoT. As narrowband IoT devices and connectivity costs will soon be very, very close to the market target price. In order to embed it in every single light controlling unit. We can also consider the KTM or higher LT category devices that will allow you to have cameras or sensors around it, and maybe even with artificial intelligence engine built right in to perform the real-time analytics and take prompt action to keep things flowing smoothly for the city and its citizens. So I would just like to go a little bit more on what already Joseph mentioned at the beginning. There has been a lot of research, and I would like to mention the Navigant research that includes smart city projects in over 221 cities, and quarter of which are deploying the smart city lighting, ranging from some initial pilots to citywide and regional deployments, and they span from tens or even hundreds of thousands of lights. And it's far from an exhaustive list of street lighting projects, but it's a further sign that it's a growing momentum behind the deployment of connecting light cities. And if you take really the numbers, I think Joseph actually mentioned at the beginning, it's 73 million connected street lights to be globally deployed by 2026. It's really huge. But the important thing behind that is that smart city lighting is being recognized by many city leaders as the first step towards the deployment of the smart city. In addition of increasing the energy efficiency that we saw, reduction of energy costs, carbon emission, or maintenance costs, it can also provide the real backbone for a range of other city applications, including public safety, traffic management, smart parking, environmental monitoring, or even extended Wi-Fi and cellular communication. So now I would like to show you what will actually 5G be able to do for the cities and how it will make possible this massive deployment. So we should consider the part of the 5G relevant for the cities can be split in massive IoT and mission critical. Although we'll have the 5G new radio based IoT starting from release 16, which is expected by the end of 2019, with main change to allow mesh on licensed spectrum, and this will probably be very interesting also for the street light and sensor around it. I would like to underline that the 3GPP confirmed the long-term status for both narrowband IoT and CAT-M as 5G standards. So as a consequence, you can understand that the narrowband IoT and LTM deployed today are the part of the 5G family. They're both optimized for low complexity, low power, deeper coverage, and higher device density, while seamlessly coexisting with all other LTE services such as the regular mobile broadband. This makes them ideal for smart city sensors, for example. On the other side, I think that also mission-critical applications can be considered part of the smart city, such as autonomous public transportation or emergency services, which require communication with very, very high reliability and availability, as well as low end-to-end latency. Considering higher cost of this kind of technology, it could still be deployed maybe on a specific location on a lamp acting as a gateway rather than on each lamp like it would be the case for the narrowband IoT. So although we are focusing on what the new technologies will bring in, I would like to bring up an interesting fact also about the 2G. So according to the research firm ABI, the 2G IoT connection in Europe will continue to grow through 2020 and then only start receding afterwards. This is due to the fact that the narrowband IoT coverage, pricing of the hardware, and pricing of the services are only expected to realistically match the 2G between 3 to 5 years from now. So Telit's strategy is to continue investing in 2G and supporting customers that make such choice. Then I would like also to introduce the Telit's latest ad in the portfolio. It's the XC310 family, the smallest LGA form factor available in the market, which we believe would be the perfect fit for the smart lighting. It's a flexible perimeter footprint supporting various sizes. There are 94 pads, including spares, to provide Telit the flexibility to quickly deliver support for additional features as technologies, application, and market evolve very quickly. Spares can be used for modules supporting also Bluetooth, Wi-Fi, or enhanced location technologies, in addition to cellular, while maintaining the compatibility with cellular-only models. They can also be used for additional connections that may be required for new 5G-enabled features, making this a future-proof form factor. The new form factor also gives the OMS greater flexibility, efficiency, and yield during design and manufacturing. The XC310 family provides easy PCB routing while minimizing manufacturing process issues such as planarity and bending. On the picture, you can also see a unique cellular pad that facilitates correct package orientation for automated assembly. So let's go back to another topic, which is very important parameter for this market, and it's cost reduction. Telit has created a unique, innovative solution called SimWise that completely eliminates the need for the physical SIM. So if we take a look at the current manufacturing process, from the lamp, of course, that have the built-in connectivity, what you would normally do is manufacture the lightning in the factory, test it with a physical SIM, and then customize it with a new SIM depending in which region it will be deployed, and finally ship to the desired location. The SIMless solution is introducing a huge amount of hours saved in the factory. It is completely eliminating the part of the testing of the SIM and customization, as this kind of lamp with the Telit SIMless module will be already provisioned with an MNO profiles that you will use in a specific region, or maybe only with a temporary one, as the final profile will be provisioned directly in field once the device is activated. So as a benefit, you will have, of course, a smaller bill of material, easier to manage stock, and no need to do the pre-configuration. We can also go a step further and take a look at what will happen with the field deployment and how this process will be simplified. So basically the normal process would be that the product arrives at the deployment location, the field rep will install the product manually and at the desired site, and then there will be a skilled technician to test and verify if the SIM operates on the local network. Again, if we take in consideration the SIMless device, configuration process will be skipped since the standardized remote SIM provisioning technology will be used, and a skilled technician can focus on some other high-value tasks. So with this, I would conclude the Telit part. Joseph, can you take over and maybe present the poll?
Thank you. You presented some very interesting data points, particularly in terms of the cost savings that these solutions can offer. It's quite amazing when you look at up to a 75% reduction in costs, and also I think the diversity of applications. I wasn't sure if we can go through this webinar without mentioning the word 5G, but I saw you got that in. That's interesting. Because it's, of course, across all the news this last few weeks, but also you were talking in terms of, mission-critical services as well as massive deployments of, low-capacity, low-power devices. So, thank you for that. Before I turn things over to our next speaker, Roman, we've published the results as you can see, and, based on, Milena's presentation, it's no surprise that cellular comes out top. Although I think about 35% of you are just starting, so you sort of haven't made a decision. But with cellular, 15 to 23%, but not far behind. 18% is the LoRa, which is actually quite interesting. More of a non-licensed spectrum application. So now I want to introduce, I want to turn things over to Roman, who will now take us through a couple of case studies on street lighting solutions in 3 regions around the world. Over to you, Roman.
Thank you. Well, thank you for this opportunity. I will talk from the perspective of smart street lighting control solution vendor. A few words about our company. Telematics Wireless was established back in 1996 as a spin-off from large communications company called Telit Communication Systems Group. From 2008, we are a fully owned subsidiary of Singapore Technologies, which is one of the largest electronics companies in Singapore. Today, we deal with several applications in the smart city market. In advanced metering infrastructure is one of our major markets. Location-based services based on our unique terrestrial location network that we developed. Of course, smart street lighting, which will be a main topic of our discussion today. Water resource management, electronic toll collection, and some others. Majority of these applications are based on technologies that we developed for wide area network, wireless technologies, not necessarily based on cellular, and we will address this issue as well. Currently, we deployed over 14 million wireless devices globally. Out of these, over 200,000 for streetlight control, and our main market currently, geographically, for streetlight control technology are in UK, in New Zealand, Canada, US, Sweden, and also some other countries. So when we talk about streetlight control in general, we are now in the midst of, we call it twin revolutions in street lighting. It's LED conversion and the adoption of control and monitoring systems. And these two go together because it's really, well, LED case is clear. As Milena mentioned, 50 or more % of energy can be saved. And this is being adopted, this technology is being adopted all over the world today. CMS goes in many cases together with this retrofit process because it is just logistically much easier to implement CMS when you go through the retrofit, LED retrofit. And today, practically almost all the tenders that we participate for CMS, these are the tenders that involve actual part of LED conversion process. And not every LED conversion process of tender includes CMS, but almost all the CMS tenders are part of LED conversion. So maybe I'll repeat some of the issues that Milena addressed. CMS provides further electricity savings, 20% or even more. Again, it very much depends on the profile that the user wants to implement in terms of dimming and trimming and all these issues, which is also a question of geography and specific customer. Not everyone wants to dim significantly its lights. Some, to some extent, do it. So the percentage to which you can reduce the power consumption based on these profiles differs from customer to customer. There is some general accepted number in the industry that about 20% or even more can be saved. But beyond that, it is always about improved maintenance, because introducing CMS, you get full vision of your network. You know exactly what's going on in every location in the network, and you can dispatch maintenance teams immediately. And by that, you obviously improve significantly the maintenance process of your inventory. Then, obviously, safety is increased by significant reduction of downtime. As we said, better maintenance, immediate response causes much better performance of the whole network and much reduced downtime of the luminaries, which also leads to the better service to the public. Some users also value metering and billing capability of the CMS. Not everyone, but in many cases, the fact that you can measure accurately, measure energy of each individual luminaire and provide this information to the center where all that is accumulated This gives the best possible measurement tool to evaluate the real consumption of your streetlight network. And last but not least, during the recent years, there's also a consensus that streetlight control networks are probably the best platform for smart city applications, and we will address this in a minute. When we look at our telematics wireless approach to the streetlight control, is one size does not fit all. There are a lot of different solutions, and I will discuss some of these later. Many different solutions, many different network topologies and approaches, and obviously every vendor explains why his solution or her solution is better than others. There are some advantages and disadvantages in each, but from our experience, we see that different customers may have different requirements, and not only functionality requirements, but also there are different topographical conditions and urban conditions, and sometimes regulatory issues. And all of these may influence the choice of the networking topology or specific network technology for the application of streetlight control. And at least we are today proposing more than one single solution for streetlight control while analyzing the requirements of the specific customer. When we look at the topologies that are currently available and adopted for streetlight control, this general drawing actually presents all the possible topologies. On the left-hand side, you have, at the upper side, you have star topology, and there are solutions, and obviously the cellular-based solutions are represented here as well. So this is star topology, which is used, but not only cellular. Today there are other ultra-narrowband or some license band-based solutions. In our case, by the way, our system that we propose in this specific topology, we call the Galaxy, which is narrowband wide area network, or utilizing licensed frequency band. Then on the right hand side, you see the topology, which is mesh topology, which is also very popular today. I would say probably majority of currently being installations that are being deployed probably are using this specific topology, this topology usually utilizes unlicensed frequencies band, either sub-gigahertz or 2.4 gigahertz band, like ZigBee and some others. So these two topologies, I would say, probably represent all the solutions, and all of the data from the gateways, being it base stations of licensed solutions or base stations of star solutions or concentrators, gateways of mesh solutions, flow to the center, to the server, where all this data is being processed, analyzed, and delivered to the customer, enabling control of the network and provides information from the luminaires about its performance. An example of one of the networks, like for example, in our case, it's a Galaxy network, which is based on utilizes licensed frequency band at 450, 470 megahertz, which usually ensures good performance without interference. In this case, we install a single antenna on high location, covering between 6 to 15 miles radius in urban environments. One single base station can cover up to 50,000 light control units. And some of the unique features in this specific network is that every node, every LCU or light control unit can also serve as a repeater for one additional hop, thus creating a capability to cover dead zones or even increase the range if needed. Auckland, New Zealand is one of the locations where we deployed such system covering the whole city, this is one of the, from our perspective, one of the better solutions for urban environment. Then another topology, which is mesh network. In our case, it's Telit Pro. Usually, these are multi-hop, self-configuring, and self-healing and scalable networks. We operate on sub-gigahertz band in 900 megahertz or 800 or 900 megahertz, depending on the geography in Europe or in US and some other countries. One single gateway, which we call it data concentrator unit or DCU, can support a cluster of up to 1,000 LCUs. But of course, you can build a very wide area coverage using multiple clusters, all of them fed into the one single server and under one system. Example of such a system you can see here. We deployed it in one of the cities in UK in Southern-on-Sea. Also deployed the system in one of the large counties in UK. All this information, of course, all this system is supported by a web-based platform. We call our platform Bright City. It's GIS-based platform where you can see all your luminaires, their status. You can enter and see individual performance of a luminaire. You can program either individually or group programming luminaires profiles, operational profiles in terms of dimming on and off times, etc. And of course, you receive all the information from luminaires, alerts if something is wrong, associated emails or SMS sent to the proper personnel in real time to handle the problem, and of course statistical data which provides statistics about the performance, overall system performance. Latest addition to our narrow band networks, and all these networks that we discussed until now are narrow band networks. One of the interesting additions, recent additions, is a special node that we developed. We call it LCU-C, C for cellular. And this node has exactly the same configuration, mechanical configuration as all other nodes, but it is based on LTE and Wi-Fi with Wi-Fi connectivity. And this node has triple function. Of course, one of them is being streetlight control node, in which case, instead of using narrowband network, it will use LTE. But in addition, this node provides access points to LTE network for sensors which are equipped with Wi-Fi connectivity, and these can be cameras and any other wideband Wi-Fi based sensor. Several sensors can be located around this node, around the pole, which includes this node with a luminaire with this node, and all of them will be fed into LTE network. In addition, the same node can serve as an access point to the internet for people, either specific, obviously with specific passwords, etc. It can be either general public, or it can be also personnel, relevant personnel. They can use such nodes scattered all around the city. And you can imagine in a city, there's no need to put such a node in every single luminaire, but in the city where there's a lot of narrow band nodes, some of them can be replaced by this wideband node with wideband capability and provide these specific unique features. We installed such nodes for example, in Auckland, in one of the parks where cameras are connected to these nodes, and these nodes serve both as streetlight control nodes and this kind of wireless wideband access points. This is an example of our cooperation with Telit. We use Telit modems for this specific product, and we see it as a significant implementation of a narrowband network. Okay, as we said, streetlight control network, we see it as a platform for smart city application, and in the implementation of the network, as I described before, when luminaires are actually everywhere and they are power supplied and they possess built-in radio network device, every single luminaire node can act as additional gateway to some other sensors around it, and bring these sensors into the network and enhance capabilities, providing additional applications. And some of them, I'd like to show you some of them, and these are actual applications that we today already implement in our networks. Utility meter reading. All is needed that utility meter will communicate with the nearest luminary node, and from there on it will become part of the network, and its information can be delivered further. And this is especially valuable when we talk about meters which are for example, water meters which are installed under the ground inside some manholes under the cover, in which case the communication range that you can maintain with such devices is very limited, and these are battery operated devices, but obviously capability to communicate with the nearest luminaire, which is usually not farther than few tens of meters away, that will enable actually advanced metering infrastructure concept for water metering without building additional network for that. Another application that is already implemented is sewage and drain water monitoring. And again, the same concept. Usually these radio devices are installed within manholes under the cover of other metal covers. And the way, instead of building a dedicated network for these devices, using the CMS where every CMS for streetlight controls, where every node can be an access point or gateway. Even I'm talking about narrowband nodes, and we are here talking about narrowband applications. This is a unique situation where you can use such deployment and provide this connectivity between sensors which are installed in challenging environments, like here, for example, and communicate with the nearest node. Further, additional application, water pressure monitoring. Again, I'm showing you here with the picture on the right side. These are existing products which already are and projects which are already implemented. So again, a CMS network, and you can communicate from various pressure monitoring sensors scattered around the city, and there's no need to build additional infrastructure. All it needs to do, the radio of this pressure transceiver will communicate with the closest node, and from there it is part of the network, and of course information is fed into its specific application software and presented properly to the users. Other applications which are available today, we did not yet integrated these applications with our system, but these are applications that you probably know and hear about. it should be waste container monitoring. These waste container monitoring enable a more effective and efficient collection of waste containers, waste bins, where radio devices sensing with special sensors, usually ultrasonic and some others, sense how full the bin is. The information is transmitted to the nearest luminaire, and from there it becomes part of the network where you can deliver this information to the proper user. Parking space detection, again, placing small radio devices in the pavement inside the road with sensors that feel the presence of heavy metal body above, and this information again can be transmitted to the nearest luminaire, and from there this data can be delivered to those who value this data. Another example of utilizing the streetlight control network for other applications, and as presented here. So these are some examples of applications. Some of them we use today, some of them we work on now, and obviously here the sky is the limit. As long as you use this kind of narrow band network, and this narrow band network capacity is adequate to address these kind of applications. So let's look at the issue of how we see the streetlight control network's future, when we look at the streetlight control network evolution, the first networks were based on PLC technology, power line communication technology. There are still obviously solutions which are proposed based on this technology, mainly in continental Europe and China. These are probably the largest markets which currently use this technology. However, during the years after, we saw adoption of wireless networks, and one of the reasons was that in some geographic area using PLC was prohibitive because of the structure of power network. In some areas, it was found that wireless networks is probably more reliable and more cost effective. And today there are a variety of wireless solutions. Some are more proprietary, some more standardized. Although even standardized, in many cases, they're not. Standard is not yet ensures interoperability. So these are, I refer to them also as some kind of more proprietary solutions, and they utilize different technologies and topologies. They operate on licensed band, unlicensed frequency band, utilize star or mesh networking topology, etc. And these wireless solutions currently are, they are the current leaders in this field. Absolute majority of solutions, at least during the latest years, last years, they are of this kind. But then again, after smart city concept became more and more relevant, we see introduction of really open standards for IoT, which are LoRa and NB-IoT. We see today, we don't yet see a very deep penetration of these technologies for streetlight control. There are many pilots, of course, there are many tests, etc. as a part of larger smart city concepts, but there are not yet too many real projects or mass projects on LoRa and especially in NB-IoT. I think that we will see this more and more as the smart city trend will pick up more and more, and will go beyond this initial phase of pilots into real deployments. And as we see today, the main application in smart city for this wide area networks is street light control. In my opinion, the main challenge for NB-IoT to become a significant player and in this field is establishing a competitive business model. I think that you see, we are very familiar with the market, and we sell this equipment a lot. We participate in many tenders, and the cost issue is very important here. And it seems that currently, at least with current price tag for NB-IoT, not so much even at the node side, although this is also must be addressed, but also at the side of the airtime, of the networking cost. Currently, seems still in absolute majority cases too high to properly compete with current existing wireless technologies that are dominating the market today. So I believe that once this cost will go down significantly, in this case, the NB-IoT will probably be, if not the technology of choice, but at least will take a very important place among solutions for street light control networks. So thank you very much. This is what I wanted to present.
Thank you very much, Roman, for those interesting case studies. I found it fascinating that you mentioned the twin revolutions. As someone covering the telecoms market very specifically, it's easy to forget that the advances enabling smart lighting is not just on the control and monitoring systems, but also on the actual light themselves, as you mentioned, the LEDs. In addition, you really outlined the use cases beyond, lighting, which is the topic for this webinar, but also you touched on, similar uses such as utility metering, water monitoring, and even parking space detection. So I think that all of those are part of the smart city initiatives popping up around the world. And lastly, you talked about the need to establish a business case, which is evolving very, very quickly. So we've received quite a few questions from our audience, and so we're going to start going through those in a second. But I just want to remind you, if you would like to ask a question, please do so. The field for typing in your query should be just below the slides, and feel free to type as many questions as you want. So I'm going to take it from the first question that came in, and this one's addressed specifically for Milena. What advantages do you see with new cellular technologies compared to current RF solutions on the market?
Thank you, Joseph. So first of all, I would say that it's ease of installation, and I don't refer only to plug and play, but also the new generation of chipsets have GNSS included, and considering the high lamp cost and the cases of loss of lamps, it is very important to use this additional technology for the localization. Then another important thing is and have open solutions, and this is what actually most of the municipalities are targeting. They want to have an open solution from technology and platform perspective both, and something available worldwide, which makes much more easier than the shipping, and provides the proven user cases can be used for the cities in different world areas.
Great. Yeah, the openness issue is obviously huge, especially when you look on a global scale. Turning to the next question, and this one's for Roman. How does the smart city concept affect street lighting network solutions?
Okay. A majority of the solutions that we have today, deployed today, are, as I mentioned before, are some kind of proprietary solutions, and these are usually optimally adapted and focused on streetlight control specifically. And today, the concept of new concept of smart city concept affects affects the networking approach in two directions. One is that these currently deployed networks, or these networks that are, as I mentioned, are leaders today in this deployment concept. They are gearing towards addition of new sensors, new applications on top of these networks. And I've demonstrated several of the applications that are currently available and will be available. So this is one direction, is to add more sensors on the same proprietary type of networks. However, another and probably even more important influence is that in this case the advantages of truly open standards like LoRa and NB-IoT are probably more visible because these come as maybe not these technologies are not designed specifically for streetlight control, but for more general concept of IoT. And obviously it enables a huge ecosystem of vendors that can bring their solutions on the same networks with many other applications. Of course, that requires very thorough design and verification with the network from the capacity perspective will support all these, etc. But at least I believe that once these kind of open standards emerge, smart cities can be realized more easier. However, I'd like from that perspective mention some negative impact as well. Some municipalities, we see it, some municipalities, they're delaying the CMS deployments until decision about smart city concept. And this decision takes some time. So in order to make streetlight control as a part of smart city, they say, let's wait, let's decide what we want, and after that we will engage in streetlight control, and that to some extent has a negative impact on the deployment of CMS network.
Great, thanks. Wow, we're receiving quite a few questions coming in here. I don't think we're going to be able to get to them all today. I apologize for that, but really, thank you so much for your interest in your fantastic queries. So I think it's almost on the hour, so I think we have time for just two more questions. So turning to the next one, what are the main issues that interest end users when choosing the optimal street lighting control system? And that's for Roman.
Okay, so many of the functionalities of streetlight control is independent of network technology. These more depend on capabilities of the node in terms of its performance, metering capability, calculation capability, and of course the application software, which provides a major part of the functionality. And these two are practically independent from the network technology which is being chosen. From the network technology perspective, the main issues that are of interest to the customers are reliability and security. And practically, they don't really care what kind of network you propose, as long as it will address their reliability and security concerns. But of course, beyond that, there are issues of capacity and latency, and of course, let's not forget the cost. I think that today, with the smart city concept, new requirements emerged, and these are adding new applications, and these may have more direct influence on the choice of the specific technology.
Great, thanks so much. I think our final question is a really interesting one, and touches on a point Milena talked about towards the end of her presentation. SIMless cellular devices are key to mass adoption across the smart lighting ecosystem. What is your solution, and when do you see operators embracing SIMless globally?
Well, I think this is an inevitable direction for the massive IoT. Also, operators are looking into it, and we expect to see some propositions in 2019. And this is also driven by the increasing demand for industrial-grade IoT devices. Even embedded SIMs are expensive, complex, and need dedicated space. Of course, as module manufacturer, we support also those. So this is not an issue for us, but we see additional advantages with this kind of integrated SIM technology, because it is direct. SIM functionalities are directly implemented in the module. It is a dramatically smaller footprint. It includes secure remote provisioning, integrated cryptographic capabilities, since there is a dedicated area in the chip that is where the same provisioning profiles get stored. So there is an important level of security, and it's done at the manufacturing site, or we can use standard UICC, let's say, technology provisioning. Telit already introduced the SIMwise on the Mobile World Congress this year, and we deployed it with 2G in Europe. And as far as regarding the narrowband and the CAT-M products, we had a demo on European Utility Week, and this feature will be launched in mass production on this kind of products by in the beginning of next year. Actually, there was another interesting question, Joseph, that I think maybe I can just quickly answer. It was about and if we expect some standardization for the communication. I think that one day it's like a dream. So one day we will take probably connectivity for granted, and we will just be creative and build a lot of application around it, and maybe we will not need to bang our heads against the wall on choice of technology.
Great, thanks so much. I'm afraid we're out of time for this webinar, and I want to thank everyone for joining, our audience across the world, and also our two speakers. But I just want to touch on a couple of key takeaways. You know, we've heard that smart street lighting is central to smart city initiatives. You know, and cities around the world are already realizing significant cost savings with these smart street lighting solutions. And in addition, innovations in IoT modular technologies, as we just heard, are also helping to reduce costs. So I think, you know, look at this space, and we're going to see you know, a rapid evolution. You know, especially as we move to these new SIM modules, in the near future. So again, thanks everybody for tuning in, and everybody have a great day. Thank you.